Hi, my name's Ellie Derringer, and today I will be teaching you how to use the law of sines in order to find unknown side lengths or angle measurements. Here's the formula. Sine of angle A over side A is equal to sine of angle B over side B, which is also equal to sine of angle C over side C. Each side and angle are directly opposite of each other, which is very important in order to correctly use this formula to find the answers. But when do we even use the law of sines? Well, the law of sines can be used when you have either an obtuse or acute triangle, where two of the side lengths are known and one of the angle measurements is known. However, the angle measurement must be directly opposite from one of the known side lengths. Let's go ahead and start out with an example. In this obtuse triangle, we know angle A, which is 20 degrees, since angles B and C are already present. We also know side A, since it is directly opposite from angle A, which is 13 centimeters, and side B, because it is directly opposite from angle B, which is 27 centimeters. This is enough information to use the formula to find the rest of the angles and side lengths. In order to find those other unknown angle measurements and side lengths, we must create one complete fraction and one incomplete fraction. The complete fraction must have 100% of the information present. For example, with this case, sine of 20 over 13. The incomplete fraction must have 50% of the information. With this example, would be sine of b over 27. We don't know what angle b is, which we're trying to solve for, but we do know the opposite side length, 27. Then, you set the two fractions equal to each other in a proportion, just as the formula states. Then you have sine of 20 over 13 is equal to sine of b over 27. Now you simply solve the proportion. In order to do so, you cross-multiply sine of 20 and 27, and cross-multiply sine of b times 13. Sine of 20 times 27 is 9.23454387, which is equal to sine of b times 13. Then, you must divide by 13 on both sides in order to get sine of b by itself, and eventually just angle b itself. Remember, it is very important to use as many decimal places as you can, or second answer, on your calculator in order to find the most accurate answer possible. Then, once you divide by 13, you'll find that sine of b is equal to 0.71035. The next step to get b by itself is to simply divide by sine on both sides, as algebra dictates. But how on earth are we going to divide by sine? Sine itself is not a numerical value. It is simply an operation that can then be used on other numerical values. So how are we going to divide by it? Instead of dividing by sine, we're going to multiply the unit by inverse sine, or arcsine, or sine -1. So in this case, we'll have arcsine times 0.71035. Arcsine, inverse sine, and sine -1 are all synonymous and are used instead of dividing by sine. Once you multiply by arcsine, you find that angle B is equal to 45.26336104 if you go into very specific decimals, or 45.3 degrees. Now we only have one missing angle measurement and one missing side length, which can be solved for using the law of sines yet again. Just like in any other triangle, angles A, B, and C all have to equal 180, which can be used to find angle C. Angle A is 20 degrees and angle B is 45.3 degrees, so those two, 65.3, plus C equal 180. Using algebra, we subtract 65.3 from both sides, and then we have our answer. Angle C is equal to 114.7 degrees. Now we know all of our angle measurements and only have one missing side length, which we can easily solve for using the law of sines. Just like before, we create one complete fraction where 100% of the information is known, sine of 20 over 13, and set that equal to sine of 114.7 over side C, because that is 50% of the known information and is an incomplete fraction. Just like before, the angles and side measurements must be directly opposite from each other in order for this to work. Then you need to cross multiply both sides, just as you do with any proportion, and you end up with 11.8106 being equal to sine of 20 times c. Then, to get c by itself, you must divide both sides by sine of 20, which is perfectly feasible because sine of 20 is a numerical value, and we don't need to use arcsine. Once we divide both sides by sine of 20, we find that side c is equal to 34.532 centimeters, which then gives you all of the known side lengths and all known angle measurements in our example triangle. Let's try another example. With this triangle, we have angles x and y and angle measurement of 19. We also have the side lengths of 15 inches, 35 inches, and then side q. Even though they aren't angles A, B, and C, or sides A, B, and C, the same principles can be applied with different numbers or variables. Using the same formula, we have sine of 19 over 35 being equal to sine of x over 15. We now have one complete fraction and one incomplete fraction, just as we need in order to solve it. Also, both side lengths and angle measurements are directly opposite from each other. In order to find x, we must cross multiply sine of 19 and 15, and then divide by 35. Once that is done, you'll find that sine of x is equal to 0.13953. Then, to get x completely alone, we must multiply 0.13953 times arcsine, which then gives us 8.02060453. We can then round that number to 8.02 degrees. Since all three angle measurements must equal 180, if we add 8.02 and 19 degrees, which gives you 27.02 degrees, plus y, then it must equal 180. From then on, you can simply use algebra to solve for y. Once you subtract 27.02 from 180, you'll find that angle y is equal to 152.98 degrees. Then you have all three angle measurements and only one side length to solve for, side q. We can use law of sines again. Then we set up our proportion with our incomplete and complete fractions, our complete fraction being sine of 19 over 35, and our incomplete fraction being sine of 152.98 over q. These side and angle measurements are directly opposite from each other, as they must be. Once we cross multiply, we find that 15.9005522 is equal to sine of 19 times q. Then, to get q completely by itself, we must divide both sides by sine of 19, which is a numerical value, so we don't need to use arcsine. Once that is completed, you will find that q is equal to 48.8394. Then, we know all three angle measurements and all three side lengths. That was how to use the law of sines when there are unknown angle measurements or side lengths. Thanks for watching.